Hello students, let us review Oscillations chapter of class 11. See what is a periodic motion? A motion which repeats itself after regular intervals of time is a periodic motion. It can be linear. Suppose if I pull this mass, it will do oscillations. As the spring will pull it back, when get compressed, it will push it back. So it is linear oscillation. Similarly, a pendulum, you have a arc oscillations. Then we have this planet revolution around the sun is also periodic oscillation. Suppose this is an equipment whose equipment is running, it will vibrate up and down, left and right, it will vibrate. This is also a periodic oscillation. The whole study is to see that how this is prevented. Okay. Now, what is oscillatory motion? All to and fro motions are oscillatory. It need not be periodic. It may not be a time bound. It will go up, come back. It may not be a time bound. That is oscillatory motion. But if I need a simple harmonic motion, harmonic means sine or cos curve. Sine or cosine function is harmonic. So if my displacement is in the form of sine or cosine, if displacement is a function of sine or cosine, it is a simple harmonic motion. Sine or cosine means what? It will not cross a maximum amplitude. It will come back. Plus, minus, it will be moving from plus to plus a to minus a, plus 1 to minus 1. So, the fundamental rule of simple harmonic motion is force should be proportional to minus x. Force should be proportional to minus x. This is the condition for simple harmonic motion. What is force? Ma. So, the Ma should be proportional to minus x. If I remove, let us say kx. So, a force is proportional to minus kx. Let us see this spring. So, for this ball is hanging freely. So, spring is slightly stretched to compensate the mg of the ball. So, now it is in equilibrium position. If it is given a small y, maybe say 1 mm or 0.5 mm, stretch and leave it, so it will do oscillations. It will do oscillations. So when I pull it here, what is the force? Kx. But this is the x direction and the force is opposite to x direction. It is pulling it back. So when it is in the upward direction, it is getting pushed. Suppose this is pushed to upwards, kx. Here it is compressed. Again it will push it outwards. So always force is opposite to x direction. If I pull this side, it will pull it. If I push this side, it will push it. So it is opposite direction. So this is a clear-cut example of simple harmonic motion. Same is here also. If I pull it and leave it, if I am pulling means force is opposite. As I pull, x is more, the force is more. Kx will be more. As I compress it more, kx in this direction is more. So the force and x are in opposite direction. K is what? Spring compression. Spring constant. K is spring constant. Force is kx. So force is equal to minus kx. It is the displacement function again becomes sine or cos theta. Let us say y is a displacement, a sine omega t. Because the simple harmonic motion is sine or cos theta. So a is the amplitude. It is the maximum distance we are pulling and leaving. Suppose I am pulling 1 mm and leaving, here a is 1 mm. So y is a sine omega t. What is y? Y is from 1 mm plus 1 mm to minus 1 mm, it will oscillate. So that whatever distance, plus 1 mm to minus mm, whatever value comes, it is y. So it is an arbitrary time with respect to time. So I am defining the extension with respect to time. This is y are nothing but x. That we are defining with respect to time. Y is equal to a sine omega t. What is omega? Is angular frequency. It is defined as 2 pi by time period. What is this time period? Suppose I pulled it 1 mm and left it. So from here it goes to the initial equilibrium position, then go back to again 1 mm up, it will come back. So it is taking one cycle. From here going up or coming back is one cycle. Again going up or coming back is second cycle. So time taken for one cycle, that is 2 pi by t. This is the time taken for one cycle. So angular frequency is defined as the time in radians. So 2 pi by t. It is defined as 2 pi by t. Suppose time is 1 of frequency. So frequency will become omega is 2 pi frequency. When 1 by t is frequency, so frequency comes up. So 2 pi f is the omega. This is omega what we are talking here. So what is its velocity? When it is moving up and down, the dy by dt is its velocity. So dy by dt is a omega cos omega t. Dy by dt is a omega cos omega t. So I can write this as a omega sin omega t plus pi by 2. That means what? This is sin omega. This is sin omega t plus pi by 2. So there is a phase difference between displacement and velocity, a pi by 2. That means when displacement is full, velocity is 0. When displacement is 0, velocity is maximum. Pi by 2 means what? Sin pi by 2 is 0, 1, cos pi by 2 is 0, and when sin 0 is 0, cos 0 is 1. So they behave in a alternative manner. Will go down. So what is the acceleration? dv by dt. When I do dv by dt, how much it is? Minus a omega square sin omega t. Cos omega t differentiation is minus sin omega t. So minus a omega square sin omega t. How it is defined as? This is acceleration. So minus a omega square sin omega square t. This is nothing but a minus omega square. What is a sin omega t? Y is a sin omega t. So this is become minus omega square y. See simply here acceleration. If I put mass both sides, if I put mass, m into acceleration is equal to minus omega square m into y. So if I put mass here, m into a is minus k by m. I will come back here. Acceleration is minus omega square y. So here if you compare this acceleration minus omega square and f is minus kx. So f is ma. When a is left, m is sent here minus k by m x. The acceleration is minus k by m x. Here how much have we got by differentiations? Acceleration is minus omega square y. So that means omega square is k by m. So this is k by mx omega square x. Y means in the x direction it is x, y direction it is y. No. So is the displacement. So omega square is k by m. How the omega square? So omega is the angular frequency. Omega is the angular frequency by which the displacement is defined with respect to time. This is the maximum amplitude. So now we got k by m as omega square. Now what is the time period? 2 pi by omega. So 2 pi by root of m by k. 2 pi by root of m by k is time period of this oscillation. So it will, if it is m is the mass of the ball, k is the this for constant, spring constant. So the time period it takes for a small oscillation is 2 pi root m by k. Suppose if I take spring weight also into consideration, this is m. Spring is also having some mass. From here to here there is some mass. It is also oscillating. So if I take spring also, so spring mass by 3. I have to add to the total mass. So 2 pi root m plus m spring by 3 divided by k. This is the time period of a simple oscillating spring. The same here. Move here. This is a time period. Here also we will calculate time period. So these are all time period based on omega. So all this time period how we got? Because the fundamental of simple harmonic motion is the force is proportional to minus kx, opposite to k, opposite to x direction. Force is opposite to x direction. So same thing I am showing here. So at t is 0, it is at plus y. The ball is at topmost y. So as time goes, it comes down ball. When ball comes to middle position, it is coming to the displacement 0, equilibrium position. When it is further, because of its velocity, it is going further down. So it is going minus y. So when again it is taking the upward direction, it is taking this route. So again comes to equilibrium position, again go back to original topmost position. So the ball movement of y we can represent in terms of a circular, the amplitude in a circular motion. So here is y amplitude, at the equilibrium position amplitude is 0, at bottom position amplitude is minus y, here again 0. So this is how we can represent. So at any point y is a, this if amplitude is a sine omega, a cos omega t. This is phi, this I have given phi. So a cos phi is its amplitude. Suppose if it is at this angle, it is a cos phi. If it is a starting point, cos phi is 0, so it will be a. So highest amplitude at the top point. So this is a cos omega t. What is this equation? Y is equal to a cos omega t. What is this omega t? Omega t is nothing but angular displacement. See, omega is theta. Theta is omega t. Theta is omega t. It is angular displacement is angular velocity into time. So this is theta. So a cos theta at any point of time will give its distance of the ball from its equilibrium position. The same thing I am representing here. So at time 0 it is at a topmost position. So at time t by 4, this is t by 4, this is t by 2, this is 3 by 4 t, this is again t. So again cycle repeats. This is simple harmonic motion represented by sine or cos theta. So here I am representing it cos theta. So at t by 4 it comes to 0 amplitude, it is 0. At t by 2 it is minus a, it is coming to minus a. At 3t by 4 it is again 0, it is 0. Then at t it comes back to 0. This is one cycle is complete and this repeat. So if I see velocity is again y is minus a sine omega t. A omega sine omega t. So there is a pi difference between acceleration, this is a displacement and velocity. See the velocity curve at this topmost point and time is 0, velocity is 0. When displacement is 0, velocity is maximum. Minus means what? It is going down. Velocity is in the bottom direction. So this all minus means what? Velocity is coming down. So velocity is in the direction of downward direction. I have represented as minus. Then again it goes to t by 2. Velocity is 0 at this position. Then it comes back. So velocity is maximum. So like that, the velocity is a pi by 2 phase difference with displacement because dy by dt is velocity a sine omega t minus a sine omega t. That is why it become minus. So now I am looking for acceleration is d square y by dt square. So it becomes a omega square sine minus a omega square sine omega t. What is this acceleration? Minus a omega square sine omega t. I am double differentiating. If you see, observe this curve. So this distance is a omega square. This distance is a omega square. This is the maximum acceleration amplitude. So when x is g plus y, y is minus a max. Then it's coming up and taking this. So this, even though this and displacement are in same phase, this is also sine omega t. This is also sine omega t. Minus omega square y, acceleration minus omega square y. Both are in same phase but minus. So when it is plus, it is minus. When it is going to minus, it is coming to plus. When it is going to plus, again it is going to minus. So there is only minus is the difference between these two, but phase is same. Phase is same. So that means 180 degree phase out. I don't say phase is same. It is 180 degree phase out. When I say y minus cos omega t, I can write it as omega t 180 minus omega t. Cos omega t 180 minus omega t is minus cos omega t. So this is I got. So this is 180 degree phase out. This is 90 degree phase out. This is 0 degree phase out. When it is starting from amplitude here. Suppose in the equation I say y is a sine omega t. This is y a cos omega t we have already seen. Now let us say y is a sine omega. Let us say another case. Y is a sine omega t. That means at t is 0, what is y? 0. So I am taking this as my starting point. In place of maximum amplitude, I am taking this as my starting point. Then the equation becomes y is a sine omega t. When t is t by 4, it goes to maximum. Again t by 2, it is 0. When t minus 2, it is maximum. When t, it is 0. So a sine omega t represented by y and velocity represented by dy by dt, but a cos omega t. Where is velocity is dy by dt, a omega cos omega t. So when time is 0, what is velocity? A omega. Here maximum velocity. It moves with maximum velocity. And goes here to velocity becomes 0 because it is taking reverse direction. So velocity becomes 0. So at the end, when this is t by 4, the velocity is becoming 0. So when it is become pi by 2, cos 90 is 0, so velocity is 0 at this point and as well as at this point. So the two curves we are representing with initial phase as y as full amplitude is ya cos omega t, y has 0 amplitude as y has a sin omega t, and accordingly the phase of velocity, phase of acceleration changes. It is only the initial position. Sometimes we can represent initial position as omega t plus some phi also. Phi means initial position I can start from here or I can start from here. So as per the problem, I can start from here anywhere. So this is omega t plus phi. If I represent initial position, then I can see the time period starts from this point. So time can be started here. It can start from 0. It can start from here also. It can be started from here also. So out of this one cycle, it can be started from anywhere as a phi. So the equation of simple harmonic motion, the starting point gives the first equation, then velocities and other things will come. Please note why we are discussing so much is the superposition to next we will get of the waves, sinusoidal waves. All electromagnetic waves are sinusoidal. All this light interference, sound interference, all these are superposition. The superposition or interference, if we understand this movement, so we can better understand those problems. Okay, you can go to now. You see, velocity is what? A sin a cos omega t. We have seen here what is velocity. Y is a cos omega t. Y is a sin omega t. Other case. So dy by dt is y is a cos omega t. Velocity is a omega sin omega t. Because I am differentiating dy by dt. So a omega sin omega t minus of course. So what is sin omega? Sin omega t. Sin omega t is 1 minus 1 y square by a square. Cos omega t is y by a. Phi means omega t. Theta is omega angular displacement. So y by a. So cos sin phi is 1 minus y square by a square under root. So then velocity becomes a omega into square root of 1 minus y square by a square. If I simplify it, velocity is omega root a square minus y square. Suppose if y is a, then velocity is 0. So whether you take a sin omega t as a starting point or you take cos omega t as a starting point, but when amplitude is at a, velocity is 0 irrespective of only time period changes. The start of time changes, but velocity is 0 here, velocity is 0 here, and velocity is maximum here. Similarly for acceleration is maximum here, acceleration is 0 here, acceleration is again maximum the opposite side. So here acceleration is positive, here acceleration is negative. So if you see here, if you put y is 0, that means it is center position. So velocity is a omega. See, velocity is a omega sin omega t. When the center position sin omega t becomes 1, 90 degree. So when it is 90, so maximum velocity is how much? A omega. So it has become a omega. So similarly for acceleration, a omega square cos omega t. Okay, understood this? Now we'll go to next. See, in a simple harmonic motion, the total energy is conserved. Total energy is conserved. If you see, okay, here, if you see this pendulum, this ball is at a height. When it is coming here, the potential energy is converted to kinetic energy. Again it goes up, potential energy, kinetic energy is converted to potential energy. Again comes back, same way. So same thing is shown here. At this point, the potential energy is minimum. Kinetic energy is maximum. So when the ball is at this point, here potential energy is maximum, kinetic energy is 0. So at this point. So I am representing kinetic energy first. So at this extreme left end, kinetic energy is 0. When it comes to center, equilibrium position, maximum velocity. Again it comes to other extreme position, 0. Similarly, potential energy is opposite. When you add these two, we will get total energy is same. This is mgh is the total energy. This is mass mg into this height. This height is the total energy. Whether it is mgh or it is half mv square, it is all the same. So half mv square means a square omega square. Mgh means half kx square. You know, energy stored in a spring is half k x square, half k y square. So both are same. From this also, if you see, half k y square is equal to half m a square omega square. When I equate it, omega is k by m. Omega square is k by m. Here also we can equate. This is the angular frequency. Okay, this is what we are seeing. So at any point of when PE is Ke, when partition energy is Ke, these 2 points PE, Ke are difference, then what is the Y? I am equating. Y is equal to A by root 2. So if this is from here it is A. So this is A by root 2. Here the both potential and contingencies are equal. So if you see here the sinusoidal velocities, sine 45 is sine omega t, 2 pi by t into t is pi by 4, t is t by 8. So by the time it reaches from here, it is t by 4 plus t by 4. So by t by 8, it reaches a distance of how much? A by root 2. T by 8 covers A by root 2. It is not covering A by 2. It is covering A by root 2. Root 2 is 1.416. More length, more y it is covering in first T by 8 because here velocities are more. At this point maximum velocity, as it goes down, velocity goes down. So in T by 8th time, it is not covering half, it is covering more than half. The balance portion is covered by another T by 8th time. Total is T by 4 plus T by 4. T by 4 plus T by 4, total T. So this is the difference. It is not simply A by 2 in T by 8. It is A by root 2. Note down this point. So now let us find out time period of various applications. Here we have seen what is the time period in this case. In a spring case, what is the time period? T is equal to 2 pi by omega. We know omega is k by m. Where it is written? Omega is, it's not there. Okay, we'll see the above. Here it is. Omega square is k by m. So time is equal to 2 pi by omega. So 2 pi root k by m. 2 pi root m by k. This is what we have discussed earlier. 2 pi root m plus spring by 3, mass of spring by 3 by k if we consider mass of spring. So this is the time period of a simple spring attached mass. So let us see for other cases the time period. Simple pendulum. So what is this? Mg sin theta is acting here. This is a force. Mg sin theta into L is the torque. So mg sin theta into L, mgl sin theta is equal to I alpha. I for ball is ml square. Because ball mass is here, I am considering this string as massless. So this is ml square. This is the I into alpha. So when sin theta is so small, less than 10 degree, less than 7 degree like that, so it will be replaced by theta. Mgl theta is ml square alpha. So this is in the alpha is d square theta by dt square. So it is in the angular acceleration is equal to m by g by L into angular displacement. So that is a linear acceleration. What we have seen earlier is k by x, kx is linear acceleration. Here is what? F is minus kx. ma is minus kx. A is linear acceleration, x is linear displacement. Same is applicable for angular also. In case of ma, I am putting m alpha d square alpha or alpha. Acceleration can be alpha and s can be theta. Here also the omega, angular omega is same. So here it comes alpha. ml square alpha is minus mgl theta. So alpha is equal to minus g by l theta. This is omega square. This is omega square. So then when the time period is 2 pi by omega is 2 pi root of L by G. So for a simple pendulum, time period is 2 pi root of L by G. Suppose if this length of cord is very long, it is earth, it is a very long cord. So before going to this, just reconfirm. So what is the equation we got? This is a fundamental approach for every problem. So mg, what is the torque? What is I alpha? So acceleration mgl sin theta is equal to I alpha. So if I keep it as I, here this is as mgl theta. So what it is becoming? I by mg becomes I by mgl. The what is as I. So I into I by mg by mg by I, mgr by I. So this is fundamental for all the equations. Here I have made ml square. So get cancelled, ll get cancelled. It becomes g by l. G by L theta. So omega square is G by L 2 pi by omega. Now let us see this. So what is this theta? Mg sin theta is acting on this chord 90 degree. What is this theta? This is Mg because earth center is having Mg. So this is theta. Let us say this is phi. So what is this angle is 180 minus theta plus phi because this is a triangle 180 degree. So if it is 180 minus theta plus phi, if I draw a line straight line, so this is theta plus phi. So mg sin theta plus phi, if you see the equation, mg sin theta plus phi into L. This is the torque on the system. It is not in this direction. If it will be in this direction if my mg is vertical down. But my mg is not vertical down here. Mg is not down. Mg is in this direction. Mg is in this direction. So mgl sin theta plus phi is perpendicular to this chord. This is the torque. So mgl sin theta plus phi into L is equal to I alpha. This is the ball which is doing pendulum. This is earth I am showing size here, but the ball is pendulum. So ml square alpha again L. So if you see here, this is L into theta is how much? This is the arc length. L into theta is the arc length. So equal to R into phi. R into phi. Both are equated. So if I substitute that, omega square is equal to G by L into theta plus phi. The R phi is L theta. So it will become G into 1 by L plus 1 by R. So when time period is 2 pi by omega. 2 pi by root 1 by G into 1 by L plus 1 by R. If I substitute L as infinity, if the length of chord is infinity, then what it becomes? 2 pi root R by G. 2 pi root, this 1 by L becomes 0. So R goes to up 2 pi root R by G, it is 85 minutes. Similarly, if I put L is equal to R, so this equation becomes 2 pi root R by 2G, that is around 25 minutes. So this is how the mg is in this direction and I want mg in this direction. This is the torque creating, which is causing I alpha. So this is mg sin alpha plus theta. Mg cos alpha plus theta is in this direction and perpendicularly mg sin alpha plus theta. Okay. Now you see the other thing. Suppose you are going in a lift and the simple pendulum is hanging. What is this time period? 2 pi root L by G. So G is always replaced by G effective. So when lift is going up with acceleration A, G effective is G plus A. Okay. G effective is G plus A. So if lift is going up with acceleration A, the effective G is G plus A. So 2 pi root L by G plus A will be the time period for a simple pendulum in lift. Same thing if lift is going down, 2 pi root L by G minus A. Suppose it is going in a slope. So what is G here? G effective is G cos theta. So 2 pi root L by G cos theta is the time period in this motion. If a truck is moving with acceleration A, truck is moving like this, G is acting like this. So what is the G effective? G square plus A square under root. So 2 pi root L by G effective, whereas G effective is root of G square plus A square. So let us take a time period of a bar pendulum. If I give a small theta and leave it, so it will do oscillations from this support. It will do oscillations. What is this mg is at which point? L by 2. So mg into L by 2 sine theta is the force into L by 2. mg into L by 2 into sine theta is the torque, which is equal to I alpha. In fact, I do not say I alpha, it is IA alpha. It is is IA because it is hinged from this point. So what is I at this point? I at the center is ml square by 12. But I at end is ml square by 3. So I put ml square by 3 alpha. So the time is 2 pi root L by mgl 2 by 2. So 2 pi root 2 by 3l 2g by 2l 2 pi root 2l by 3g. Okay, 2l by 3g. This 2 comes up, l square goes up, ml square, and 2 by root is correct. I will correct it. 2 pi root 2l by 3g, because here mg is acting at a distance of l by 2 from the strong. So this is for a bar pendulum. So let us understand what is the seconds pendulum. Second pendulum time period is 2 pi root l by g, and it is 2 seconds. 2 seconds means what? By the time it goes, what is seconds pendulum? From here it goes to other end, come back to here, it takes 2 seconds. Again it goes, come back here, 2 seconds. That is seconds pendulum. So in a seconds pendulum, if I put to t is 2 seconds and g is 9.81, I will get L as 1 meter. Very clear. So second pendulum is of length 1 meter, g 9.81. If I start doing oscillations, I will get 2 seconds. So what is a conical pendulum? This conical pendulum, what is the time period? What time period means what? By the time it take one revolution, this is time period. So if you see the equation, mg is equal to tension cos theta. So that means tension sin theta is equal to mv square by r. This is m omega square r. mv square by r or mr omega square, both are same, from which we get omega square is g by h. So time period is 2 pi root h by g. This is h. This is L. So 2 pi root h by g. This is mr omega square is countering the mg tan theta. This force. mg tan theta is again r by h. So when we simplify it, we get 2 pi root h by g. So there is an electrical oscillating circuit. What is omega square is 1 by root 1 by LC, we know. So omega is 2 pi by L or 1 by 2 pi C. When I put omega square, it becomes 1 by omega 1 by LC. So omega is 1 by root LC. So for an electrical oscillating circuit which is operating under a capacitance and an inductance, when they are in resonance, and therefore omega is equal, 2 pi by L and 2 pi C both are equal. So when they equal, so time period of the resonance circuit is 2 pi root LC. 2 pi by omega, so LC comes upwards. So 2 pi root LC is the time period for electrical oscillating circuit. Suppose this ball is there, it is rolling like this. It is rolling. What is this length? This length is R minus R. So 2 pi root L by G. 2 pi root R minus R by G is it is a frictionless surface. So it is oscillating. 2 pi root L by G. Here the resultant L is R minus R. So now let us see a compound pendulum. Let us see this rectangular thing is supported S. Center of the support is A and B. I give a small theta. Then you start oscillating. This frame starts oscillating. So what are the equations here? So mg d sin theta. Let us assume from here to here is d. This is mg, and the perpendicular to this mg sin theta into d. This is the torque on that, which is equal to is alpha, which is nothing but is alpha. How is alpha is taken? Ic plus mr square. This is a parallel axis theorem. Ic plus mr square is equal to is. This is we called as d. Okay, Ic plus md square is is. So Ic plus md square will become, how much is Ic is what? M into a square plus b square by 12. This is for a rectangular plate. This is the I through center. I ms. This is I b square by 12. This is I a square by 12. So when I add I into a square plus b square by 12 through center. So when I add md square for this, I will get is into alpha, from which I can get the time period. So Ic plus mb square by 4 is is. Here in this case, what is is? This is hanging here. So mr square, r is a square plus b square is r square. So this is if it is a by 2 plus b by 2. So a square by 4 plus b square by 4 is r square. So m into b square. This is a square plus b square. So this length is taken as 2a. So this is a square plus b square is mr square. In this case, yes. So finally, what is the time period? 2 pi root I by mgr. Time period is 2 pi root I by mgd. I by mgd. So here, what is mgd? Here d is this distance. Here d is this distance. So 2 pi root I is again is, where it is hanging. So we should know from this and add the mr square. So 2 pi root I by mgd is the time period for such compound pendulums. So I have given IC for rectangle. Suppose if it is for a ring, suppose a ring is hanging. What is mr square is the I plus another mr square. So it becomes 2 mr square. So here in place of I, what I have to put? 2 mr square. If you suppose it is a disc, so the I through this is mr square by 2 plus mr square. So it becomes 3 by 2 mr square. So in place of I should put 3 by 2 mr square. So depending on the I of the compound pendulum, I can have to replace this I with is where it is supported. So 2 pi root I by mgr is its r is again distance from the support. So this is again the compound pendulum's time period. Let us say a torsion pendulum. This is c into theta is the torque. C into theta is I alpha. C into theta is I alpha. If it is a disc, again I is mr square by 2. Because it is rotating from center, so mr square by 2 maintains. There is no addition. No other mr square is getting added because it's still rotating at center. So mr square by 2 I. So in that case, 2 pi root I by c. 2 pi root I by c. So oscillations in a U-tube. Let us understand this U-tube. Suppose there is a DH. Top there is DH, bottom there is DH. So what is this difference? Is rho area into 2dh into g. This is the mass. This is the weight of the difference. What is this? Rho a 2dh means dh top, dh bottom into g. So this is the force acting. What is the mass acceleration? What is the mass? This whole fluid is accelerating. So mass of the fluid is rho a into 2h. This is the mass into acceleration. Rho a 2h. 2h is 1h here plus 1h here. I am assuming here it is coming into this 2h. So this is the total mass. Rho a 2h into a is oscillated with this acceleration a. M into a is equal to, what is the driving force? This dh. 2dh is the driving. This difference, it will try to maintain its both level, try to maintain like a spring. You have given up, it will come down, again go up. It will come down and go up. So this is oscillation. So the time period for such U-tube oscillations are 2 pi root h by g. This is h. So this is similar to 2 pi root L by g. For a simple pendulum it is L by g. For a torsion pendulum I by c. Like that here is 2 pi root h by g. Now let us take a drum here. Floating in a tank. How much height is floating? H height is floating. So here the oscillation of this is 2 pi root h by g. How it is calculated? Suppose if I give it a small push inside, a dh or dx. Mass of the drum, initially it is balanced by Bion's force of the liquid. So h portion is depth. So if you take a uniform cross section A, rho A h into g. Rho A h is volume. Volume of water displaced. What is this? AH is volume of water displaced. So rho is water. Rho AH into G, this is the force of water displaced, is equal to mg of. What is mg? Total mass. Mass into acceleration. So what is mass here? Rho AH. So when I push it by dx, then what is the buoyant force excess it is acting upon? Rho A G into delta x. So A into delta x is the excess volume that is displaced. So rho in volume into g is the excess buoyant force. So it is creating acceleration to the entire mass. So mass is rho ah. So rho ah into acceleration. So here we got acceleration and displacement. So time period is 2 pi root of h by g. Similarly, for if there are two, the if it is fully submerged, and we give a oscillation, so in that case, what is this? The two different densities. Rho 1 A G D H is the Bayes force is equal to rho 2 A L into A is the acceleration. Rho 2 A L is its mass. Rho 2 A L is mass. Rho 1 A D H is Bayes offered by the medium. So if I do this, so how much omega I am getting? Rho 1 G by rho 2 L. So the time period is 2 pi root L by L rho by rho G. Here is case of 2 pi root h by g. Simple. Here we have two different mediums. So 2 pi root L rho by rho g. So this is the time period to fully submerged, and we have given oscillations. Here only h amount of length only it is floating with h itself. So I have equated the Bayes force and mass and converted into one. Here both are taken, both densities are taken into consideration. Here it is 2 pi root h by g, here 2 pi root L rho by rho g. By equating this delta h, when I give push, there is a buoyant force acting on that. Rho L A G. Rho 1 is medium. Okay. Now you see that there is a dipole, electric dipole plus Q minus Q in external magnetic field. What is the, if I give a small theta oscillation, so how it is, what is the time period of this oscillation? So what is the torque acting on this M cross B. M is Q into 2L. M is magnetic moment or electrical dipole moment, Q into 2L. So M cross B is equal to Q 2L sine theta, which is equal to I alpha. What is I alpha of this rod? ML square by 12. Here L is 2L, because I have taken is 2L here. So here also 2L. So M 2L square by 12 alpha. When I do this, the time period I am getting 2 pi root ml by 6q. So similar, same is for magnetic dipole moment. Instead of 6q, I am using m itself, I by m. I is ml square by 12 and m is magnetic moment, m cross b. So both can be applied here. So this is electric dipole. Now we take the simple harmonic motion. Suppose if a particle is doing simple harmonic motion on the earth. If it is the center, so it is pulling. So I am giving a small displacement. So it is oscillating. So how it is oscillating? What is the time period? Let us see here. So what is G at this point? G is equal to G into, if this distance is x, G into x by r. G is G into d by r. The distance is d, this is G into d by r from the center. So this is acceleration due to gravity. Here it is G, here it is 0, it is G into d by r. So if I say what is tan theta here? Tan theta is, if this is x, x by d. Tan theta is x by d. That means d tan theta or sin theta. D sin theta is x. So if I make an equation, mg dash sin theta is equal to ma. This is mg. G is G into d by r. Mg, if it cannot come here because there is a slot here, so it's frictionless slot, so this has to come this side. What is this is mg sin theta in this direction. It is mg sin theta is a force, it is pulling it down, which is making this m acceleration, providing acceleration to this ma. So mg dash sin theta is equal to ma. When g dash is g into d by r and sin theta can become theta. So when I equate it, I am getting omega square as g by r. So time period is 2 pi root of r by g, again 85 minutes. So it does not matter whether this is d here or whether it is very extreme or it is the center, because in my time equation the d is not coming into picture. D is not coming into picture. Neither this x is coming into picture. It is simply r by g, because all are getting cancelled here. This x is the displacement, is a small displacement. If x is more than theta, I cannot take sin theta as theta, so it is a small, let us assume small displacement. But anywhere if I give oscillations around in this sphere, so this is taking a time period of 85 minutes. So you have seen in all the examples what we have seen, 2 pi root inertial factor by spring factor. So 2 pi root m by k for a spring system, 2 pi root I by m for this body system, for your compound pendulum, I by mg r. M is a momentum, mg r, force into distance, mg r. I by mg r. For other things, 2 pi r by g we have seen here, or 2 pi I by g. So like that, mgr, again L by g. This is L by g. So the inertial factor by spring factor gives the time period, all the oscillations. So let us come to springs. Suppose spring is K. You have cut it in, you have added two springs in series. So then the effective spring constant is 1 by K is 1 by K1 plus 1 by K2. How it has become? Total expansion under the force is x1 plus x2. So force is common. So mg by K1 plus mg by K2 is equal to mg by K effective. So 1 by K effective is equal to 1 by K1 plus 1 by K2. If they are in series, so x is equal to x1 is equal to x2. So then kx is equal to k1x plus k2x. So k is k1 plus. This is like capacitance. The spring is acting like a capacitance. So whereas in series 1 by C is equal to 1 by C1 plus 1 by C2. In parallel C is equal to C1 plus C2. It is not, it is opposite to resistance. It is not acting like resistance. Series is different. 1 by series is R1 plus R2. But here it is 1 by R, K is equal to 1 by K1 plus 1 by K2. So similarly for parallel, K is equal to K1 plus is acting like a capacitance equivalence in series, capacitance equivalence in parallel. Suppose if spring is cut. So if it is cut, spring constant will become Nk. If it cut n times, then each spring constant is Nk. If I add all these things in series, what will happen? 1 by Nk plus 1 by Nk plus 1 by Nk plus 1 by Nk. Total becomes N by Nk, it becomes 1 by K. So original spring constant. Because of the series connection, the equivalence. So if a spring is cut in n pieces, it becomes n. If cut in 2 pieces, 2k. 4 pieces, 4k. So accordingly, time period varies. Accordingly, frequency t is t0 by root n, and frequency is root n f0. So this is the when the spring cut, the time period. Because 2 pi root L by g, t is 2 pi root m by k, k is coming under bottom, k is n times k. So 2 pi root t over root n. Let us say if spring is cut in terms of L1 is 1 n L2. Suppose L2 is 0.5. L1 is 1.5. Then what is it become? 1.3 L2. So both together becomes 2 L2. 2 L. So this is the ratio example. So if it is cut into n L2, then what is the K1 is n plus 1 by n into K. And K2 is n plus 1 by, which is more? N plus 1 into K. Because K2 is smaller one. K2 is smaller. As it goes smaller, the spring constant will be increasing. As it is longer, spring constant will be reducing. It is reduced by n times. So if I do this in parallel connection, n plus 1 by n plus 1 by n by n plus 1 plus 1 by n plus 1 becomes n plus 1 by n plus 1. They get cancelled, you become k. So again, original shape in series. So that is why we have to cross check whether this individual spring constant, when I am adding in series, series means 1 by k is 1 by k1 plus 1 by k2. I should come back to k. So this is the, if the smaller the length, more the spring constant. So if they, suppose if spring is subject to two masses, that means instead of one mass, I put another mass here. So then I stretched both the masses. Left it is doing a oscillations, both masses. In that case, how we have to take? In that case, I have to take a reduced mass. So m1, m2 by m1 plus m2 reduced mass. Then you can use 2 pi root m by k. 2 pi root m by k we can use. Only thing is, I have to replace m by m1 plus m1 m2 by m1 plus m2. So now what is resonance? When applied frequency is equal to the natural frequency. What is natural frequency? F. Omega is equal to 2 pi f. So f is omega by 2 pi or 1 by t. 1 by t time period. Then the intensity increases by 4 times because a square. amplitude increases by 2 times 2a, the intensity increases by 4 times a square, so 4a square, so 4 times. So then this will lead to a destructive and damage to the equipment. So to alter the natural frequency, what is in my our hand? Omega square is k, m by k. So I can reduce, either I can change the m, or I can change the stiffness, and I can change the natural frequency of the system. So whenever there is high vibrations in equipment, we will add either mass or we will remove mass. So then the external vibrations and the machine vibrations are different, so resonance will not occur. Okay. Now let us see Lissaj's figures. What is Lissaj's figure? Suppose, as I told you, if particle is operating on simple harmonic motion in this direction, so the medium particle moves as a sin omega t or a cos omega t. Suppose particle is also having this movement, a sin omega t and a cos omega t. So it is having both x direction, both y direction. Then what will happen? Here it is a sin omega t plus phi, here is a sin omega t. Both way, let us say frequency is same, and this is at phi phase difference with this one. So the equivalent will come here. So if I add these two 90 degrees, a2 sin omega t plus phi, a1 sin omega t, if I add, x1 is a sin omega t, so sin omega t is x by a1. Y is a2 sin omega t plus phi, sin a cos b plus cos a sin b. Here I am replacing sin omega t by x by a1 and cos omega t by 1 minus sin squared omega t. If I replace here, finally I will get this equation. X square by a1 square plus y square by a2 square minus 2xy by a1 a2 cos phi. Phi is the phase difference between them is equal to sin squared phi. This is the equation with which the particle is moving vertical motion as well as horizontal motion. Let us see some cases here. Suppose both omega are same. Omega 1 is equal to omega 2 and a1 is equal to a2. Both amplitude is same. That means by the time it moves from x direction, it moves to a1, a, y also moves to a. So they are moving, the particle is moving like this. Again it is coming back. Again it is going. So the frequency is same. Omega, so by the time it is going extreme position coming back, the y also going extreme position coming back. So this is the resultant path. It moves in a diagonal line. Suppose if it is having a 45 degree, so let us see, here is a horizontal line, is a vertical line, then this will be a by root 2. This interconnection will be a by root 2. This line is here is a by root minus a by root 2. This is minus a by root 2. So at a by, when x is 0, suppose if you put it here, phi is 45. Sin 45 is what? 1 by 2. And a is the same. So a1, a2 are same. Then becomes what? If I see this, a by root 2 when x is 0. When x is 0, the y becomes a by root 2. Here is. When y is 0, when this is x is 0, y is plus or minus a by root 2. When x is 0, y is plus or minus a by root 2. When y is 0, x is plus or minus a by root 2. So like that, the particle vibration goes on like this. Suppose if it is 590, that means what? By the time it is 90, x direction, y is 0. By the time x direction is minus 90, y is 0. By the time x is 0, y is full. By the time x is 0, y is full. So it is a circle. The particle is moving in the equipment is moving in a circle. The vibrating particle medium is moving in a circle. Because by the time x is 0, y is full. Y is 0, x is full. Both sides. This is a reverse direction. Now suppose you take a case, wy is half of wx. That means x is 2 times y. Suppose by the time the particle, the vibrating particle goes to extreme and come back, y it goes one time. Again goes to extreme and comes back, again y comes back one time. See, when this is going up, coming back, y is going to only half distance. It is going up to this extreme x, y is going to half distance. When coming back, y is covering other half distance. Similarly, same. So if this is the 8th figure we are getting. This is one of the Lissaj's figures. So if x wy is half of wx and both are same amplitude, you are getting the particle is moving like this. Understand? By the time y it makes one up and down t by 2 connection, x goes 2 times. Again same the bottom. By the time it's having x direction, y is half. By the time it's come back, y is covered other half. This is sinusoidal coverage it is doing. Okay. So this is it. So if it is 45, it is tilting this side. If it is 135, it is tilting this side. So particle goes like this, comes like this. If it is phi is 90 degree, that means what? By the time x is 90, y is 0. By the time it's coming to from here, it is going to other end. It is the y is coming from 0 to full length, full y. Again, it is coming to 0. It is coming to 0. So the other side, by the time x is having from left to right, y is having one side. So it is a C. This is how Lissaj's figures form in the combination of x and y movement. Let us see the damping. This is a damping equation. Suppose x is a sin omega t plus phi. This is our fundamental displacement in a simple harmonic motion. It is an undamped one. Suppose if I provide a damping here, the a will be go on reducing. The amplitude will be go on reducing and sometimes it will stop oscillating. So what is this? A becomes a0 into e to the power of minus bt by 2m. So b is damping constant. bt, t is time, m is mass. So a0 into e to the power of minus bt by 2m sine omega dash t plus phi. The omega also changes. Omega becomes omega dash t plus phi is the equation for a damped condition, where b is the velocity damping coefficient. If you see the same thing, if I see in the equation, earlier undamping is ma plus kx is 0. Now we have given a by minus is a velocity. See, even all damping like viscosity is a damping, friction is a damping. So all these things will have directly velocity. Viscosity is proportional to velocity. Like that, all damping are proportional to velocity. So minus by. This is the thing reducing the amplitude. So if I convert this into this, d square a is d square by dt square plus 2 mu dy by dt, 2 mu dy by dt plus k is omega square k by m comes here. So m is coming b by m it is coming here, k by m it is coming here. K by m is omega square x, y I am writing in terms of y, so omega square y is equal to 0. So k by m is omega square, so 2 mu is equal to b by m. 2 mu is equal to minus b by m. So this is the mu is the damping fraction, mu is b by 2. So what is omega dash? Here again omega dash is square root of omega square minus mu square. This is mu, b by 2m. So omega mu square is b square by 4m square. B square by, this is what omega dash is. Square root of k by m, omega square is k by m minus b square by 4m square. This is the mu. So omega square minus square. So if you see omega dash square is omega square minus mu square. If mu comes this side, so omega square is the resultant is equal to omega dash square plus mu square. So if it is omega dash here, mu in this direction, so this is omega. It is equivalent resultant of omega dash square plus mu square is equal to omega square. So this is how omega dash is defined as square root of omega square minus mu square, whereas mu is equal to minus b by 2m, it comes here. So then comes t dash, t is equal to 2 pi by omega dash. Finally the system is moving with omega dash. So omega dash is continuously will be reducing because it is a damping provided. So 2 pi by omega dash is this. So t is greater than t because omega square minus mu square is a smaller than omega square. So that means it is more time it is taking. Suppose if you see here, if mu is far greater than omega, means damping is far greater, then it will suddenly fall to 0 position amplitude. If mu is far less than omega, it will some more time to take to do still oscillations, and as goes on, it reduces its amplitude. If in between, it will behave in a in between manner. So depending on the damping we are providing, the rate of reduction can be controlled. So why we provide damping? Suppose the equipment is there, the instrument is wobbling. For a reading, it is taking a wobbling, it is an oscillation. So I don't want oscillation. So I provide some damping so that it will come to a stable position and give me a reading. Okay, that is the reason I provide. I want it to come to stop quickly. It should come to the reading area and it should stop. It should not wobble at the reading area. So I provide a small damping. Like that is damping sometimes we use. Now another point here is forced vibrations. Here we are damping. Here what we are providing? We are providing forced. I want the equipment to vibrate in particular fashion. So I am giving forced vibration. How it is defined as d square y by dt square, this is acceleration, plus 2 mu dy by dt, this is the damping. 2 mu dy by dt is the damping. Mu is minus b by 2m, same, plus omega square y. It is same as this. So everything I have equal to F external by mass. Means what is this? F external by mass means acceleration external. Is the acceleration cos omega dash t. So I am providing some acceleration here. This total is acceleration because d square by d square is acceleration. 2 mu dy by dt is acceleration. Omega square y is also acceleration. Omega square is 1 by second square. This is meters per second square acceleration. So unless it is same units, you cannot add. So here also acceleration. So external force by mass is acceleration into cos omega dash t. Here omega dash is same. Omega dash is root of omega square minus mu square. And mu is again minus b by 2m. It is minus b by 2m. And omega square is k by m. All are same. But the thing is, I have added this external force. Please note that if omega dash is omega, then resonance will occur because external frequency is equal to its natural frequency. So it will cause resonance and amplitude will be maximum. Okay. Now otherwise amplitude is acceleration, external acceleration, and by a by m divided by square root of 4 mu square omega dash square plus omega dash minus omega square whole square. Omega dash minus omega square whole square. What is here? Omega dash square is equal to omega square plus minus mu square. It comes to minus mu square. Omega dash square minus omega square is minus mu square into whole square. So mu to the power of 4. So this is the amplitude for a forced vibration. The derivation presently is not in the scope, but we have just given the equation here. So just to conclude it, d square y by dt square plus 2 mu dy by dt plus omega square is equal to external acceleration provided, forced acceleration provided into cos omega dash t. Again, omega dash is same as omega square minus u square. So this is the amplitude. Mu is minus b by 2m. Same here also I have given that. What is mu? Minus b by 2m. Same. So this state of force vibration in which the amplitude reaches a maximum value is known as amplitude resonance. Here omega dash is omega. So if the k is more, the amplitude will be small. That means a rugged construction will have less vibration. A light construction will have more vibration. The stiffness, basically stiffness should be the important factor in designing for the reduction of amplitude. Again, we have discussed about resonance phenomena of setting a body into vibrations by strong periodic force whose frequency coincides with natural frequency of the body.